Okay, this next problem is taking a complex number and raising it to the second power. So remember, we're using De Moivre's theorem, and so we will use the theorem. It said that z to the nth power is r to the n, and then it would be cosine of n theta plus I sine n theta. Okay, and so that would be 6 squared cosine of 2 times 7 pi over 6 plus I sine of 2 times 7 pi over 6. That's 36 cosine of 7 pi over 3 plus I sine of 7 pi over 3. So 36, and so 7 pi over 3, this is 2 pi is the same thing as 6 pi over 3, right? So 7 pi over 3 would be right here, first quadrant. Cosine would be positive 1/2, and I would be, sine would be negative, would be positive square root of 3 over 2. So we would have, that's 18 plus 18 I square root of 3. So, or 18 plus 18 square root of 3i. Makes more sense. So 18 plus 18 square root of 3i is the answer to number 5. Let's go on to number 6. We have 5 cosine pi over 2 plus I sine 5 pi over 2 raised to the 5th power. So using the theorem, we would say that's 5 to the 5th times cosine of 5 pi over 2 plus I sine of 5 pi over 2. Now, 5 to the 5th power is, hang on, I got 3,125, so 3,125. So you don't need a calculator. You can just pause your recording and do it and then come back on like you knew it all along. Okay, 5 pi over 2. Let's talk about. This is 4 pi over 2, right? 2 pi is the same thing as 4 pi over 2, so on the unit circle. And then another pi over 2 would be right here. So it's the same thing as regular pi over 2. So 5 pi over 2 is the same thing as pi over 2. So that would be 0, cosine 5 pi over 2, plus I, and then sine 5 pi over 2 would be 1. So you get 3,125 times 0 plus 3,125 times I. So it's just 3,125 I. So that was number 5 and 6.